Simple moving average crossover strategy backtest with Python. We are going to backtest the simple moving average crossover strategy today. We will use historical daily prices for Bitcoin. We will use the Python module Backtesting.py. We will first install Backtesting.py. Then we will discuss the conceptual basis of simple moving average crossover strategy. Afterwards, we will write the code together in Python, then run the code, and finally interpret the results. Installation. Pip install backtesting. That's it. But I use TALib. This is a kind of an old library, but it's very fast. Look at the description for how to install TALib videos. The concept of SMA crossover. What is moving average? In a chart, what we usually see is random fluctuations of price. However, if we take moving averages, we can smooth the data, allowing us to see price trends. The moving average, MA, is calculated for n periods. For example, if n equals 10, MA10 means 10-day moving average. For MA10 for a given day, let's call this K, we take the closing prices of the last 10 days from that given day and average them and use that as the data point. Then we move to the next day, K plus 1, and do the same calculation for this new day. The result is a line representing the 10-day moving average. The simple moving average always lags behind the current price, because the current price is only one data point in the calculation. Moving average can be taken for any number of days. For example, we can take MA20, where n equals 20. Using larger n usually results in smoother curves and allows for detecting longer trends. However, they lag behind the price more than smaller n, hence MA10 is faster and MA20 is slower to react price motion. Using two moving averages as a strategy. Can we combine two moving averages to create a trading strategy? If we assume momentum trading principle that once price has momentum, it will keep moving until it loses its momentum, we can certainly do that. Momentum means the rate of change in price, speed of the price. So if MA10 crosses over MA20, it means that the price is gaining momentum. Then the 10-day prices are performing better than the 20-day prices. This is the entry signal. As long as MA10 is above MA20, we keep the position open. When the MA20 crosses over MA10, this is our exit signal, we close the position. Coding. First, we need to import the required libraries. We will need to get the data. I already have the data in a SQLite database, so I use that. How to get and put the data into SQLite database is another subject for another video. If you want it, I can probably do it. Then we need to prepare the date field so Backtesting.py understands it. That's why we imported the datetime modules. Then we write our SMA cross strategy class. We define two period variables as class variables because we will later use them for optimization. In the init function, we pre-calculate the two moving averages using TALib. In the next function, we set the conditions for buying and closing the position. Closing the position means selling what we have, but this is a long-only strategy, so we don't go short. Finally, prepare the backtest with SMA cross strategy. We need to give it $1 million because Backtesting.py doesn't allow fractional trading. Then we run the backtest and then get the results to the output variable. Then we print the output to see the results. Then we plot the results. Afterwards, we will be doing optimization. Which periods are the best combination for the most profit? This is the question we are trying to answer. We set N1 and N2 ranges, maximize equity final in dollars, and there's a constraint that N1 must be smaller than N2. We also want the heat map. The optimize method will return us the stats and heat map variables. Stats is the result for the best N1 and N2 combination. Again, we print the results of the optimization, also plot the trades for the optimized result. We also print the best N1 and N2 values. Finally, we save the heat map to an image file. These are the results for N1 equals 10 and N2 equals 20. The chart looks like this. We made 16 trades and had a win rate of 43%. We also had a maximum drawdown of 43% and our average drawdown was 6%. Also look at the Sharpe ratio. It is below 1. We only made about half of what we would have made if we just bought and held. And here are the optimized results. We made more than buy and hold. Our maximum drawdown percentage halved and duration is now 1/5 of the previous run. We only made 3 trades and they are all to the point. They are all wins. Furthermore, we were exposed to risk only half the time. What are the magic numbers then? N1 equals 115 and N2 equals 120. They are both long-term trends. Have we found our magic? Let's look at the heat map. In the heat map, we're going to be looking for yellow areas. They are on the top on both axes. Interpretation. Did we find the Holy Grail? Can we simply use this strategy and get rich off of Bitcoin? Not quite. We definitely overfitted. Let's see if this strategy would have worked 4 years ago. We kind of did this the other way around. We should have looked at 4 years ago first and then test that optimization results with the new data. But it doesn't really matter. Old data was not within our model building domain. Let's see how it works. We only change the start date, then run the code. For N1 equals 115 and N2 equals 120 we have. Very bad, isn't it? Only 3% gains in 2 years. Look at buy and hold. 100 times that. And here are the results for the original N1 equals 10 and N2 equals 20. Much better than the optimized one. At least we made 222% returns. How about we optimize for this period? Hey, we beat the buy and hold. This time the magic numbers are 5 and 70. Let's look at the new heat map. See, they keep changing, don't they? This is what overfitting or curve fitting means. So if you think you found a strategy, you have to look forward and test it with other periods as well. Thanks for watching. Please like and subscribe.